Good morning, dear students. My name is Ferhan Mazher, and today is 16th, I think, or I think 17th of. Let me check the date. I think that today is 17th of September 2009, and today is Friday. And my name is Ferhan Mazher, and I am with the 9 Matric class. And the subject we are studying is physics. So we are on the third chapter of the physics. This is ninth Matric class, and the name of the chapter is dynamics, and we are working on its theory. And today we are going to study about the Newton's second law of motion. So Newton's second law of motion is very simple. It is about when you apply force, a net force. It means that the force is not balanced. When you apply force, acceleration is produced in a body. Okay. So first of all, if I want to you need to understand that I am using two very important terms. I am using the word force, and I am also using the word acceleration. So what do the acceleration means? Before you go start studying the Newton's second law of motion, acceleration basically means that a change in the velocity. And when I say change in the velocity, it can mean both the things. It might mean that the velocity will increase. That is a change in the velocity. It also means that there might be a decrease in the velocity. And it might also means that the magnitude of the velocity might change or may not change, but the direction will change. Or magnitude and the direction, they both change. So acceleration is basically change in velocity per unit time. Or in simple word, you can say that it is change in velocity. But technically we say change in velocity per unit time. So in 1 second, how much the velocity changes? That is called acceleration. And the acceleration can be positive, it can be negative. Positive acceleration means that the velocity is increasing, and we call it acceleration. And when the velocity is decreasing, means the velocity decreases gradually, the acceleration value will be negative, and we call it acceleration, but we have a proper word for this. We use two words for this purpose. When the velocity is decreasing, at that moment the acceleration is not called acceleration. It can be called acceleration, but we have a special words for it. We call it retardation, or we call it deceleration. You have studied this in your previous chapter. The acceleration is equals to Vf minus Vi divided by T. That is the first equation of the motion. Vf minus Vi divided by T means final velocity minus the initial velocity, the whole thing divided by T. So that's acceleration. The Newton's second law of motion is about the acceleration which is produced in a body and the unbalanced force, or the net force, or the resultant force. You see, the Newton's second law of motion says that the statement is very simple, that the acceleration which is produced in a body is directly proportional to the net force. The magnitude of this, the acceleration produced in a body, is directly proportional to the net force. It means if the net force will be larger, the acceleration produced will be also larger. If the net force will be smaller, the acceleration produced will be also smaller. So it means that the acceleration produced in a body is directly proportional to the net force acting on the body. And this is the one statement, it is directly proportional to the net force. And the second portion of this statement is it is inversely proportional to the mass of the body. Inversely proportional to the mass of the body means that it can means the more the mass, the less will be the acceleration. For example, I can give you an example. For example, you have a Land Cruiser. and you have a Mehran car. So the Land Cruiser's mass is larger, it's heavy, and the Mehran is very light. For example, Leah and Hania, they are going on a trip and their battery is dead. So their car is now not starting. So now they have to push the car to start it. So the both the girls will have the same force. I mean, together they are pushing the car. So if they have Mehran car, so when they both will push the car will get a higher speed. But if both these girls were in a Land Cruiser and now they have to push a Land Cruiser, so they both will have the same force. Now, when they will apply the force on the Land Cruiser, the velocity they will gain, that will be not that much. It will be less as compared to the Mehran got the velocity. The velocity which the Mehran achieved when Hania and Leah they are pushing the car, that will be Mehran will get higher velocity, but the Land Cruiser will get less velocity. The reason, because Hania and Leah, when working together, they produce the same force on the Mehran car, they produce the same force on the Land Cruiser. But why did the Mehran got more velocity as compared to the Land Cruiser when they are pushing it? The force in both the cases is same, but the reason is the Mehran has less mass. It is lightweight. Mehran's mass is less. Land Cruiser's mass is larger. So the same force when applied on Mehran will produce a greater acceleration, and the same force when applied on a Land Cruiser will produce a less acceleration. The reason is the Mehran has less mass and the Land Cruiser has a larger mass. So you see, the statement is that the acceleration produced in a body is inversely proportional to the mass of the body. If the mass will be larger, the acceleration produced in the body will be less for the same force. And if the mass is smaller, then the acceleration produced will be larger. So two sentences in this law. One is that when you apply a force on a body, when there is a net force acting on a body, it produces acceleration in the body in the direction of the net force. Whatever is the direction of the net force, in the same direction the acceleration will produce. The acceleration produced is directly proportional to the force, the net force, and is inversely proportional to the mass of the body. So I can write this thing mathematically. You see, we can write this mathematically. So you can see this first sentence. This is the mathematically how you say acceleration is directly proportional to F. This first mathematical sentence coming up, that is known as F proportional, directly proportional to F. This. And the second sentence is F is inversely proportional to M. When we want to represent inversely, we write 1 by. So because the acceleration produced is inversely proportional to the mass of the body, so I wrote here A proportional 1 by M. 1 by M means that the A and M, they are inversely proportional. So you join both these. You join both these in a single sentence. So you will say A is proportional to F by M. So you know that so this M can be taken to the other side, F proportional to MA. And when you remove the proportional, you introduce a constant here. That constant is K. And in the SI units, the value of the K is 1. So the formula becomes F equals to MA. F equals to MA, a very, very important and famous formula. F equals to, that is the mathematical form of the Newton's second law of motion. F equals to MA.
Sir,
F
can you
means,
define it again?
You see, this says that the acceleration produced is directly proportional to the force, net force. Mathematically, we write this sentence like this: F proportional to F. Second sentence is F is inversely proportional to the mass. When you want to represent the inversely proportional, you write 1 divided by that thing. So we wrote A proportional to 1 by M. So you combine these two. So you can write F A proportional F by M. Take this M to the other side. So F proportional MA. In your D2 Maths chapter number 1, you must have studied that when we remove the proportional sign, we introduce equal sign, we have to put a constant here. So we put a constant K here. In the SI system, the value of the K is 1. So the formula will become F equals to MA. You need to remember this formula. F is equals to MA. F is the net force, resultant force. M is the mass of the body. A is the acceleration produced in the body. Okay. So from here, I
Yes,
can
sir.
define also from here, the unit of the force is Newton. You remember the unit we use to measure the force is Newton, and the mass is measured in kg, and the acceleration is measured in meter per second square. So from this formula, we can define 1 Newton. 1 Newton is a force that produces an acceleration of 1 meter per second square in a body of mass of 1 kg. That is known as the 1 Newton. So 1 Newton is equals to the mass is kg and the acceleration is meter per second. So the Newton can be also written as kg meter per second square. So this is how we do this. This is the second law of motion. Do you understand this really? Hello? Do you
Yes,
understand
sir.
this Newton's second law of motion? So can you tell me how
Yes,
you
sir.
will define how what is the statement of the Newton's second law of motion? Yeah. What's the statement?
Ma'am, sir, it says that when a net force acts on a body, it produces acceleration in the direction of the body. ठीक है
Yeah.
और the magnitude of the acceleration is directly proportional to the net force acting on the body and inversely proportional to the to its mass और नीचे वाली इक्वेशन याद करनी है.
What is that equation?
What is the a is equal to f, फिर f की जगह हम लिखेंगे 1/m
अच्छा,
और
रुको
a.
रुको रुको रुको। This symbol is not equal. This symbol is proportional. Okay, say proportional.
A is equal proportional to f. A is
Yeah.
equal to proportional to 1 by m. A proportional to f by m. A proportional to m. A putting as proportional constant we get f is equal to kma.
And the K value is 1. So the formula will become F is equals to MA.
Ma.
Okay. So you understand this. Here
Yes, sir.
F is the force which is measured in newtons. M is mass which is measured in kg. A is acceleration which is measured in meter per second square. So that was the okay. So here on your screen you can see we have an example. Let me reduce the size a little bit so you can understand. Find the acceleration that is produced by a force of 20 Newton in a mass of 8 kg. Here the force is given. That says 20 Newton. The mass is 8 kg. He says what is the acceleration? According to Newton's second law, F equals to ma. So put the value of F, 20 Newton, equals to put the value of M, that is 8 kg. A is question. This 8 is multiplying with the A. This 8 is multiplying with the A. So take this to the other side. When it will go on the other side, it will divide. So you will have A equals to 20 Newton divided by 8 kg. So the answer you will get is 2.5. Divide on the calculator 20 divided by 8. You will get 2.5 meter per second square. So this is how you will do this example 3.1. This is the use of the second law, that second law, Newton's second law of motion. Do you understand this example?
Yes, sir.
Okay. Umehani says yes, sir. Okay, so let's do the next example. You can do these examples in your copy. These they are present in your. Okay. He says a force acting on a body of mass 5 kg produces an acceleration of 10 meter per second square. What acceleration the same force will produce in a body of mass 8 kg? So there are two cases. We have body A, we have body B. So mass 1 is 5 kg, the mass 2 is 8 kg. So acceleration produced in the first body A or 1 is 10 meter per second square. So we will apply the Newton's law of motion, second law of motion, on the first body, and that will give you the force. F is equals to ma. You know, the mass is 5 kg and the acceleration is 10. So 5 multiplied 10, that will be 50. So the force applied on the first body is 50 Newton. Now the same force is applied on the second body. The second body is of 8 kg. So the same force is applied on that second body. So what will happen? Let me show you. Achha. So F equals to ma. Now this force on the second body is 50, the mass is 8, and the acceleration produced in the second body I want to find out. This 8 will go on the other side, so 50 divided by 8. So on your calculator you will do 50 divided 8, that will be 6.25 meter per second square. Do you understand this example? Hello? Hello? Do you understand this example? Yes. Ania says yes. Okay, so we are going to the next example. This is example number. Let me show you. This is example 3.3. A cyclist of mass 80 kg exerts a force of 200 Newton to move his bicycle with an acceleration of 3 meter per second square. How much is the force of friction between the road and the tire? Okay. Now, the mass of the cycle, the total mass is 40 kg. The force applied is 200 Newton. And the acceleration produced is 3 meter per second. So, from the second law of motion, F equals to ma. F is net force, resultant force. Remember, it is not the applied force. It is the resultant force. So F equals to ma. So F will be equals to the mass of the bicycle is 40 kg. And the acceleration produced in the bike is 3 meter per second square. So 40 multiplied 3, that will give you 120 Newton. It means that the resultant force, it means that the net force is 120 Newton. The net force which is actually producing the acceleration is only 120 Newton. But you applied 200 Newton force. But the force which produces the acceleration is only 120 Newton. You applied 200 Newton force. So where is that 80 Newton? You applied 200 Newton force, but the force which is producing the acceleration in the cycle is only 120. So how much is the difference? 80 Newton. Where does the 80 Newton went? You provided 200 Newton force, But the force which is producing acceleration, the net force, is only 120 Newton. So 80 Newton disappeared. So where does that 80 Newton went? The 80 Newton force went in overcoming the friction between the road and the tires. So what is, the net force is equals to, that's a famous formula. Net force is equals to applied force minus the force of friction. The force of friction is question here. So the net force from the second law of motion, Newton, we have found that it is 120 Newton. The applied force is 200 Newton, and the force of friction is question. So you will have F equals to 200 minus 120, and that will be 80 Newton. So the force of friction between the road and the tire is 80 Newton. Do you understand this question? Do you understand this question? Yes, sir. So that was the example
Yes, sir.
3.3. Okay, shabash, bete, shabash. Good. Okay, so now we come another term, a very famous term, and the two terms which are normally in our daily life, we take them same. But in physics, both the terms have different meanings: the mass and the weight. Okay, so mass in the physics means the amount of material, amount of matter in a body, that is known as the mass. And the weight means the force with which the earth attracts a body towards its center. So that is known as the weight of the body. Because the weight is the force. I'm saying, what is the weight? Weight is the force. Weight is the force with which the earth attracts a body towards its center. That is known as the weight of the body. So weight is force, basically, with which the earth will be attracting a body towards its center. So weight is force. So its unit will be Newton. Whereas the mass is the amount of matter possessed by the body or in a body, and its SI unit is kg. The mass is a scalar quantity. Scalar quantity means that it can be completely described with magnitude only. But weight, which is a force, it is a vector quantity. Weight is a vector quantity. It can be completely described and understood by the magnitude, and it also requires direction. The direction is always towards the center of the earth if we are talking about earth. So weight is the force with which earth attracts the body towards its center. So remember another very important thing, that the mass can be measured with the beam balance. The beam balance, the balance which the people use to measure vegetables, that is the beam balance. And the weight is measured with the Newton meter. This diagram is the Newton meter. So this diagram, you can see that on your screen. This diagram is showing up. This is the Newton meter. With the help of this Newton meter, we can measure the weight. Okay. In our Desi language, we say kanta. This is called kanta. Okay. In physics language, we say it's Newton meter. Have you seen this? Have you seen this Newton meter ever?
No, sir.
So when they measure how much, for example, you bought what we call that, you bought a bakra, and you want to measure what is the weight of the bakra, they use this. So this is called Newton meter. This Newton meter is also used to measure the, it's basically used to measure the force. So when you hung a mass with it, for example, you hung a block of wood with it, so whatever will be the extension in the spring, that will be shown up on the meter, Newton meter, and you can read, and that will give you the weight. Another very important thing is that the weight depends upon the gravity of the earth. It depends upon the gravitational field strength of the earth. Gravitational field strength is small g. For example, when you are on equator, the g value will be 10 meter per second square, or you can say 10 Newton per kg, sorry. The small g value, that is the gravitational field strength, that will be 10 Newton per kg on equator. But if you go higher, if your altitude increases, you go higher. For example, you start going on to when you are going Islamabad or Mari. So your altitude becomes higher. So what happens? You go away from the center of the earth. Your distance from the center of the earth will increase. The value of the G on the top of the, for example, you go in Mari, which is a hill station. So when you go there, your distance from the center of the earth increases. So the value of the G in the Mari will be less as compared to the value of the G in Sargodha. So there the weight will reduce a little bit. And it means the value of the weight is not constant, because it depends upon the value of the G on that location. So for example, if you are in Sargodha, the G value will be larger. But if you go on the top of the summit of the K2, there the G value will be less. So the thing whose weight here in Sargodha will be larger, and the same thing when goes to the top of the K2, its weight will be less. The reason, the G value at the top of the K2 is less. So for example, if you are in a like the owner of the Amazon, you go into the space. So when you go into the space, the value of the G will become zero at some point. And they went there and they experienced that zero gravity. So your weight will kind of become zero, and you will be flying, you will be floating in the air inside that spaceship. So weight do not remain constant. At different locations, its value will be different, because the value of the G on the different locations will be different. But the mass is something which do not change. If you measure the mass, if you, let's say I bought 2 kg rice, that's the mass of the rice. So if you measure the mass of the rice in Sargodha, it will be 2 kg. If you take same rice to the top of the Murray and you measure that rice, it will be 2 kg. You take the rice to the summit of the K2 and you measure it with the beam balance. It will be 2 kg. You take it into the space and you measure its mass, it still will be 2 kg. So the mass do not depend upon the location. So if something is 2 kg here, it will be 2 kg in Murray, it will be 2 kg on the top of the K2, it will be 2 kg in the space. Even you take it to the moon, there its mass will be 2 kg. So you understand, the mass do not change. It does not depend upon the location of the body. Whereas the weight depends upon the location. It depends upon the value of the G on that location. If the value of the G on that location is less, the weight will be less. If the value of the G on that location is larger, the weight will be larger. For example, if I weigh, let's say, the 2000 kg and 2000 Newton here. If I go to the moon, my weight will be no more 2000 Newton. It will become less. It might be just maybe 800 Newton on the moon. So the weight depends upon the value of the gravity there, the gravitational field strength. Okay? Do you understand what I'm saying? Do you understand?
Yes, sir.
Ummehani says yes. So very important formula. W is equals to mg. W is equals to mg. The very famous formula. W is equals to mg. This formula connects the weight and mass and the gravitational field strength. W is the weight. W is equals to mg. W is the weight measured in newtons. M is the mass measured in kg. G is the gravitational field strength. Gravitational field strength, its unit is Newton per kg. So don't forget this formula. Weight, W is equals to mg. You understand this thing? Do we need to read it or we just let it go? Should we go further? I need to read this or no? She says yes. You want me to read it? Okay. So the mass and the weight, generally mass and weight are considered similar quantities. So Umme, I don't understand what you're saying. Let me check your. I don't get what you are saying. Mehani is saying. Okay, so no need to read. Okay, I don't think that we need to read it. Means I mean, do you know from where I get this book? Do you know from where I get this online soft copy of this book? Yes, this is eLearn Punjab. This is that website. Learn.gov.pk. All your books are available there in the soft copy. I can download the book from there. You see, I have opened this book and I have downloaded it. I mean this chapter. Okay. So that this lesson is also due to that we have this beautiful book, with soft copy of that book, and which have made our this online lecture easier. Uh, we are very thankful to the eLearn Punjab. They have provided these books, so you can also access them, and you can download these books. Okay, so we are going to the next part. Newton's third law of motion is a very famous formula. So you see, Newton's third law of do we just have 5 minutes? So let's quickly finish this. When I apply force, for example, when I let's say I have a tennis ball and I throw the tennis ball, and the tennis ball will go and it will hit the wall, and from the wall it will bounce back and come back to me. You see, I applied the force, the ball went, the ball applied the force on the wall, and the wall applied the force on the ball, so the ball came back. For example, you must have heard this, that when you are walking, you apply the force by your feet in backward direction on the ground, and the ground apply force on your feet in forward direction. For example, when I for example if I for example the propellers, you know, the propellers of the ship, the propellers of the ship, that fan under the water, the propeller in the ship, the propeller applies force on the water, and the water applies force on the propeller. Okay, so for example, when a rocket goes up, the gases, the hot gases apply force on the air, and the air apply force on the hot gases. Or in other words, You see, whenever you apply force on a body, whenever you apply a force on a body, that body will apply the same force on you. So when the tennis ball hits the wall, the tennis ball applies force on the wall, and the wall applies the same force on the tennis ball. So tennis ball applied force on the wall, and the wall applies the force on the tennis ball. This is called Newton's third law of motion. That whenever you do action, action means you apply a force. Whenever you apply action, there will be an equal and opposite reaction. Action and reaction. For example, the ball applied the force on the wall, that is action. And the wall applied the force on the ball, that is reaction. Action and reaction both are forces measured in Newton. Action and reaction, they both are equal in magnitude. Their size will be same, but their direction will be different. You applied for the ball applied force on the wall in the, let's say, left direction. The wall will apply the force on the ball in the right direction. Action and reaction, they both are equal in magnitude but opposite in direction, plus they act on different bodies. The action is applied on the wall and the reaction is applied on the ball. So whenever you apply the action, there will be a reaction. Action and reaction, they are equal but opposite in direction. For example, you can see here these hot gases. So here the hot gases are coming down, and in the reaction the rocket is going up. Here the gas is coming out, in the reaction the balloon is going forward. Here a book is lying on the table, the force, the weight is acting downward, and this reaction of the table is acting upward. Action and reaction, they both are equal in magnitude but opposite in direction, plus they act on different bodies. Newton's third law of motion deals with the reaction of a body when a force acts on it. Let a body exerts a force on another body B. The body B reacts against this force and exert a force on the body A. The force exerted by body A on B is the action force, whereas the force exerted by the body B on A is called the reaction force. Newton's third law of motion states that to every action, there is always an equal but opposite reaction. According to this law, action is always accompanied by a reaction force, and the two forces must always be equal and opposite. Note that action and reaction forces act on different bodies. Consider a book lying on a table as shown in the figure 3.8. The weight of the book is acting on the table in the downward direction. This is the action. The reaction of the table acts on the book in the upward direction. Consider another example. Take an air-filled balloon as shown in the figure 3.9. When the balloon is set free, the air inside it rushes out and the balloon moves forward. In this example, the action is by the balloon that pushes the air out of it when set free. The reaction of the air which escapes out from the balloon acts on the balloon. It is due to this reaction of escaping air that moves the balloon forward. A rock such as shown in the figure 3.10 moves on in the same principle. When its fuel burns, hot gases escape out from its tail with a very high speed. The reaction of these gases on the rocket causes it to move opposite to the gases rushing out of its tail. So that is the Newton's third law of motion. Hopefully you have understood. The time of our lesson is also finished. Let me quickly stop this recording. So thank you very much, everybody, and it was a pleasure teaching you all. So God bless you. Have a good day.